Welcome to this presentation on permeable interlocking concrete pavers. My name is Brad Swanson, Director of Commercial Sales and Development for Unilock Midwest. To give you some background on myself, I'm starting my 15th year at Unilock. Prior to coming to Unilock, I did practice as a landscape architect for about 12 years, and I specialize in campus design, parks and recreation, athletic field complexes, and other commercial project types. I do have a bachelor's in landscape architecture and am licensed in 4 states as a landscape architect. If you have any questions about this presentation, do not hesitate to reach out. The best way to contact me is via email at brad.swanson@unilock.com, or you can call me on my cell phone at 630-742-4168. Also, if you're on LinkedIn or Instagram, feel free to follow me. I do post different projects occasionally, so please check that out. Now let me give you some background on Unilock. As you probably already know, we are a manufacturer of interlocking concrete pavers and segmental retaining walls. We have 13 locations across the Northeast, Midwest, and Canada. We're actually headquartered in Toronto, Ontario, Canada. At these different locations, we have 18 production plants, and we have over 65 territory managers on the ground ready to assist you. At all of these locations, we have an extensive dealer and contractor network, and we also have unrivaled customer service and support at each of these locations to help you with any of your project needs. You know, Unilock was the first to introduce paving stones to North America in 1972. We were also the first to introduce heavy-duty pavers to North America in 1989. And as far back as 1991, we introduced permeable pavers to North America. In 1992, we introduced FaceMix technology. Today we call our FaceMix technology EnduraColor. We are also the first to introduce an extensive authorized contractor network. You know, Unilock continues to lead styles, trends, and manufacturing technologies to deliver products with exceptional strength, beauty, and resilience. You know, Unilock can supply all your hardscape needs. We have unit paving stones, architectural slabs for like roof decks, natural stone, porcelain tile, segmental retaining walls, both structural and non-structural. At some locations, we do offer custom architectural precast, and we have all the accessory items for your installations. So sand, pedestals, edging, sealers, and cleaners. We do have in-house lunch and learn presentations, as well as live remote presentations. We have the one we're doing today on permeable pavement, but we also have architectural paving, outdoor amenity spaces, which talks about roof decks, engineered retaining walls, and we're introducing a new presentation called Engineering Segmental Paving with Confidence. And really this covers anything where pavers are used in a vehicular application. Of course, these all come with continuing education credits. Upon the completion of this presentation, you should be able to identify the benefits and opportunities for permeable pavers. You should be able to analyze the goals and criteria for using a permeable paver system. Additionally, you should be able to list permeable paver materials and be able to design different solutions. You should be able to evaluate and compare permeable paver systems to other traditional storm systems. And you should be able to understand the different installation procedures for permeable pavers. We're going to start off today's agenda with a general introduction of permeable systems. I'll talk about a few case studies to kind of give you a brief overview of some benchmark projects and kind of the range of how permeable pavers are used. We'll talk about the benefits and systematic solutions for using permeable interlocking concrete pavers, and I'll do a deep dive into storms. Then we'll talk about the design considerations, the solution options and components that go into a permeable system, and I'll also talk about lead information, how that plugs into where permeable pavers are used. At the very end, we'll talk about some of the Unilock resources that are available to you on our website. And now some general information on permeable systems. The photo shown here is of the Museum of Science and Industry in Chicago, Illinois. This is an 𝐸𝐸 permeable paver parking lot with eco-prior crosswalks as shown in black. School buses will pull in here and drop students off, and they'll actually walk across the permeable pavers to get into the museum. Now, conceptually speaking, permeable pavements designed to allow water to infiltrate off the surface to the openings in the joint. It'll flow through the granular base material and get back down into the subgrade soils, hopefully recharging any groundwater or potentially giving water and oxygen to plant material. But the main reason we see permeable pavement used is because the base material can be used for stormwater detention. We'll talk more about that here in a little bit. One of the great things about concrete pavers is the product versatility. And this is a great example of that. This is someone's backyard where they've used these different colors and textures to cut in a full dragon into their patio. And they actually have little fireballs cut in as well that shoot over to a fire pit. However, people often forget that concrete pavers were designed for heavy-duty use. So all over the world they're using these different heavy-duty applications where you have forklifts and semis driving across the concrete pavers. In the U.S., the Port of New Orleans, the Port of Tampa Bay, the Port of New Jersey all have pavers in their container yards. And actually the Port of Oakland is the largest paver yard in the U.S. at about 2 million square feet. So when you combine the aesthetics of the concrete pavers and the heavy-duty capabilities, you create a new function with permeable pavement by allowing water to flow through the openings in the joint and get back down into the subgrade soils. These are pictures of Couch Place, one of the green alleys in Chicago, that links the theater district from the Goodman Theater to the Chicago Theater. And this allows for pedestrians to walk through this corridor safely without having to dodge puddles as water will flow through those openings, but also allows for semis to pull in here, unload and reload, as well as garbage pickup. So it makes it a multi-purpose alley. Here's a great example of the product versatility of permeable pavers. This is Stonehill College on the East Coast. They've used EcoPure with 5x10 bands that run across the plaza, and EcoPure 10x10 is the larger blocks of pavers that have two colors speckled in towards the center of the plaza area. And what makes this neat is that they actually put in these little gray areas. These are little knockout areas that can remove and put in a tent structure and create a Four Seasons room. So I really like the simplicity of this design, which, in reality, you really don't have to sacrifice your design intent or your project integrity by using permeable pavement. A great design is going to transcend regardless of material type. And here's another fantastic example of permeable pavers being used in a decorative urban plaza streetscape area. This is downtown Evanston, Illinois, where they've used the Eco Promenade 3x12 permeable paver with an Umbriano finish. And these diagonal bands actually match up with the plaza on the other side of the street, and it flows across the street into this area. Another great example of using permeable pavers where you're not compromising your design intent. Part 2, Case Studies. Now I'll give a brief overview of some benchmark projects. Before I start on those, let me just mention this project on the left. This is 3rd Street in Bloomingdale, Illinois. This uses EcoPure and Thornberry permeable pavers. At one time this was the street. They closed this off to create a community plaza, but it's still a fully functional street that can actually pull the bollards out and drive cars and SUVs through here as well as emergency vehicles. Here are the 3 case studies I'm going to discuss today. Now, I want to mention that I chose these projects because I work in the city of Chicago, and these were early adapters using permeable pavement, and they really set the benchmark for how it was used throughout the city. The first one is a decorative permeable campus spine at a Loyola University called St. Ignatius Plaza. The second one is a large permeable parking lot called Guaranteed Rate Field Lot L. And the last one is a permeable pedestrian plaza called Buckingham Fountain. Now, just because these are in the city of Chicago doesn't mean they're not relevant to your location. They're still great examples of how permeable pavement's been used. Here's St. Ignatius Plaza. So this used to be a street corridor that Loyola closed down to turn into their north-south spine on the south part of their campus. And when they were doing design development, they found out that they had a very high infiltration rate into the subgrade soils, and that's because they're only a few hundred yards away from Lake Michigan. So it made sense to use permeable pavement on this project. Now you'll notice that this plaza area is fairly flat, and there's actually no surface inlets. All the water runs through the joints and back down into the subgrade soils. Now they chose to use 3 sizes out there: the EcoPure 5x5, 5x10, and 10x10 permeable paver. Now these feature a Premier and Duracolor finish on the surface, making them very fade resistant. They also chose 4 colors. So the buff colors was intended to be the bike lanes. The prairie reddish brown color was intended to be the walking areas. And then they have a couple other highlight colors, the charcoal and the granite colors. But these spaces were designed to be used for emergency vehicles, which is why they have this width, but also delineate where the different uses were. The second project I want to mention today is Lot L out at Guaranteed Rate Field, formerly U.S. Cellular Field, home of the Chicago White Sox. And this parking lot is the furthest to the south of the stadium. Now, this was installed in fall of 2008, and at the time it was the largest permeable lot in the U.S. at about 265,000 square feet. What makes this unique is that when they started designing this in 2008, the city had yet adopted any kind of green infrastructure. But the following year, in 2009, they were going to have a green infrastructure plan in place, so the mayor wanted to take a look at which way would be best to design this project. So they looked at doing a traditional parking lot design, which included 44 inlets and catch basins, over 3,000 linear feet of reinforced concrete pipe. They also had to include a 73,000 cubic foot underground storage tank. And all this would have cost about $2 million in underground infrastructure that was going to be completely buried. You never see that. So they went back to the drawing board to take a look at a green infrastructure project using permeable pavement. And the first thing they checked out were what the site soils were going to look like. And they discovered that because this used to be an old lake shore here, they had actually a very high infiltration rate, up to 14 inches per hour, into the sandy subgrade soils. That meant they could eliminate all the inlets. There's no reinforced concrete pipe or under drain, and they could eliminate the underground storage tank because they could use the granular base material underneath the parking lot as their storage area. So they ended up saving about 15% versus their traditional system. And the other great thing about this is that it does not connect to the City of Chicago stormwater system. The City of Chicago actually has a combined sanitary and stormwater system, so by dumping all this water into the stormwater system, it would cause problems in different locations. Now we'll go back through the materials here in a little bit, but I just want to mention the capacity that's out there. So this permeable lot was about 265,000 square feet. They had about 14 inches of granular base, and the void space generally is about 40%, which means you can generate about 123,000 cubic feet of storage. Now they only needed 73,000 cubic feet, so they actually have a surplus of about 50,000 cubic feet of storage on this project. Now they had 2 colors out there. They had a charcoal color and a granite color, and that was really to delineate the drive aisles from the parking aisles, or from the parking spaces. If you go out there on game day, they kind of cram as many cars out here as they possibly can. They used this mechanical installation device. They had a couple of them out there, so they're installing at least 10,000 square feet per day using the machine, and we'll talk more about that later as well. The last case study I'm going to talk about is Buckingham Fountain. And what makes this project unique is that it's an historic landmark located in downtown Chicago's Grant Park. The material that was out here was a decomposed granite / pea gravel type material in this kind of pinkish color. And this area was not accessible, so the Chicago Park District wanted to rip all this out and make this an accessible area for everyone to use. Now, when the project was completed in the spring of 2009, it was actually the largest permeable plaza in the U.S. at about 235,000 square feet. Now, the biggest challenge was installing around this fountain area because that area is about 1 acre of space to navigate around. So the contractor started at 3 o'clock, worked clockwise around to about 11 o'clock, stopped, went back to the starting point, and worked counterclockwise so they could zip this up to become one giant monolithic segmental paving surface. Now, to meet the historic preservation's requirements, they need to kind of create that same look and feel as the existing pea gravel / decomposed granite material. So they selected the Unilock series exposed granite finish. And so we take crushed granite, we embed it into the surface of the concrete, and then it's washed to create this sparkling surface. Now, if you go back out there today, it actually looks better than the day it was installed because you have more granite that's exposed and sparkling out there. They ended up using 3 sizes of the 𝐠𝐫𝐞 paver, the 5x5, 5x10, and 10x10 permeable paver, which has about a 1/4 inch wide joint to allow the water to flow through there. but still allowing this to be an accessible area. Also, this is 𝐸𝐴 lane pattern K, which we helped design so that it really minimized the lines in the lane pattern to make it more difficult to recognize. However, the contractor was actually able to memorize the pattern and lay this out completely around the fountain area, which is pretty difficult thing to do. There are 49 units in this lane pattern. And this is the view after completion in the spring of 2009, looking north towards downtown Chicago. Part 3, Benefits and Systematic Solutions for using Permeable Interlocking Concrete Pavers. So I'll start off with some quick facts about permeable pavement. It is considered a structural BMP by the EPA's National Pollution Discharge Elimination System. And what that means is that as the water flows through the granular base material, it's actually going to clean the water and it's going to improve the water quality. Permeable pavement also can reduce runoff and runoff temperature. As I mentioned earlier, the aggregate base is often used for stormwater detention. Now, if you're working with engineers on the project, they always want to know what the C value is, or the runoff coefficient. And it's actually 0. And what that means is that all the water that hits the surface is going to run through the openings in the joint, go through the granular material, and hopefully get back down into the subgrade soils. But typically, you're going to see the C value, or the runoff coefficient, at 0.25 to 0.5. And what that means is that between 25 and 50% of the water is going to run off the surface to other areas. But it really depends on your local jurisdictions. You may see those as high as 0.95, which sounds pretty high, but when you compare it to a detention pond, which has a C value of 1, that means you're actually getting a little bit of benefit from using permeable pavement. And this does not include any kind of subgrade soil infiltration as a factor. That's when we look at curve numbers, or CN value. And those would typically range from 45 to 80. And those do take in the soil permeability along with that. So we've seen CN values for permeable pavement as high as 91. Now, some additional facts, and we're going to cover these in the next few slides, so I'll kind of run through these quickly here. As I mentioned, it does reduce surface runoff. We'll talk about the rapid infiltration. We'll also talk about volume control. It does allow you to use this water for on-site use, so you can capture that water and use it for plant material or preservation of native ecosystems such as wetlands. As I mentioned before, it does improve water quality, and we'll talk about how it improves the water quality. And then you can reduce or eliminate detention ponds by using permeable pavement. We'll look at that volume control and that total capability of the system. And there's some intangibles as well. There's winter conditions to think about, and there's also ease of maintenance for using permeable pavement. Now, the first benefit I want to talk about is rapid surface infiltration. I'm going to show you a quick example here. In this video, you'll notice that we pour the water on the surface. Initially, it splatters out in many different directions, but it really only has to flow 2 or 3 inches before it gets into the joint material. It doesn't have to flow all the way across to black asphalt, heating up, picking up a lot of contaminants. It's just going to go just a little ways before it gets back into the system. So that's the initiation process, the starting of the system capturing the water. So if we look at some typical infiltration rates for 𝐸𝐴 we're looking at about 900 inches per hour. With 𝐸𝐴 we're about 600 inches per hour. And further into the presentation, I'll talk about what that means and other options of permeable pavement that we have with their infiltration rates. And then when you get to the joint material and the base, setting bed, and granular base, you might have very similar infiltration rates, 500 inches per hour up to 1,000 or more. And we know that because we use ASTM C1781 to measure that infiltration rate. So basically we put a ring down, we pour water into that ring, and we time it to see how long it flows through those openings in the joints. Now, the second benefit I want to mention is volume control or detention. And this is a great project, great example of how they used permeable pavement successfully. So out at Dominican University, when this was installed in 2003, they were starting to get more commuter students on campus. They needed additional surface parking. And when you put in surface parking with an impervious surface, you need to have adjacent detention. Well, with the permeable pavement, you're basically stacking those on top of each other. And so at Dominican, they didn't want to encroach on their green space or their athletic fields. And that's what made this project successful, because they combined them, stacked them on top of each other. So all the water that hits the surface is detained in the base beneath that. So this is a parking lot of about 375 stalls, which is about 3 acres of pavement out there. That's a lot of water that it generates. And so this base capacity can actually hold a 100-year storm. The next benefit is plant material. So you really do get some intangible benefits from using permeable pavement, and that's because, as I mentioned earlier, you're going to allow that water and oxygen to get back down to the root zone. So in this particular project, they had an existing tree out there. There's a new entry being built, and so they had to increase the walkable space so they get emergency vehicles in and out. So by using permeable pavement, it prevents the trees from being suffocated, still allows them to get that water and oxygen as needed, but still allow for those heavy-duty vehicles. And this compares to your typical big box retail, where you might have impervious parking lot areas and these little 5-foot square tree pits with trees that will be put in there. Eventually they're going to get root bound, and then really they have no reason to grow out underneath that impervious surface, because there is no oxygen or water getting through that pavement. So eventually these trees will die in these spaces. As I mentioned earlier, it does help decrease pollutants, so that's a great benefit for using permeable pavement. And what I usually kind of give an example of, this is kind of like a better water filter for the environment. So as the water flows through that granular material in the joint material, the base and subbase, it's going to capture a lot of those contaminants. And so when the water gets down to the discharge pipe or into the subgrade soils, there's a dramatic reduction in contaminants. We find that about 70 to 80 to maybe even 90% of that material gets captured in that first 2 to 3 inches of those open joints. Now there's been a lot of studies around on decreasing pollution. This one was done by the Interlocking Concrete Pavement Institute, and they looked at some different common kind of pollutants that you'll find in water, like suspended solids, phosphorus, nitrogen, and metals is another big one. So the chart here shows you what it would be like if it was just an infiltration trench, and then if they have an infiltration trench plus permeable pavement, so meaning that you're pretty much capturing all the water in the permeable pavement or the infiltration trench, and you're looking at a total suspended solids, TSS, of 95%. Metals is as high as 99%. There's been a lot of different agencies, universities that have tested this, and they come up with very similar results, that the water does get filtered as it goes through these granular base materials. Now the one thing they find that does not get filtered is salt. So if you have de-icing chemicals like sodium chloride, that is not going to be captured in this system. It's going to flow through with the water. The next great benefit I want to mention is volume control. We often call this detention. There are really two ways to manage stormwater, and that is either through volume control by slowing the water down and detaining it, or through conveyance, meaning get the water downstream away from your property as fast as possible. So with permeable pavement, because it has that rapid infiltration, water can flow through that area and then be stored in the base, as I mentioned a few times now. And really, when you go to use permeable pavement, you can actually reduce that detention pond size, because your surface is impervious. You're allowing that water to get through the joints into the base material, and hopefully you'll get some infiltration to the subgrade soils. Now when you use permeable pavement, that might change your calculations for your site properties, your overall stormwater requirements, so that you can have additional usable space. So in this example on the screen here, this is a municipal police parking lot. It was a lead building, and they used permeable pavement to help meet the lead reflectivity for that area, but also they needed to cut down that detention pond size. So by using a permeable lot and refining their calculations, they're actually able to make their police facility slightly bigger. And the other great thing about permeable pavement is that slowing down of that first flush. So when you get that heavy downpour, all the water wants to run off impervious site as quick as possible. With this, it goes into the base. You can slow that water down and hold it there for a period of time so you're not causing other problems downstream like erosion or flooding. So really, when you're doing site projects, the goal is to maintain and reduce the post-development discharge from the pre-development discharge. So you want those two to balance. So if you're working on a completely, site where there's not been any work done before, it's a green space, turf area, you want to try to balance that so that it doesn't change any of the watershed area around it. For the next benefit, I'm going to go off on a little bit of a tangent and talk about rainstorms. Specifically, I want to explain intensity and quantity and the effectiveness of permeable paver systems. So if we start at the top here, which photo is showing more water being sprayed? Is it the watering can on the left, or is it the person holding the hose on the right? Well, this is a little bit of a trick question here. We can tell that the photo on the right has a more intensity. We don't know which one actually dumped more water on the surface, and I'll explain that in a second. For the bottom photos, which one is showing more flooding? Well, it's pretty obvious that the photo on the right has more water. There's definitely more flooding there, so we know that's probably a more greater quantity. But if these were two separate events, we would know which one had a higher intensity. The photo on the right could have taken a full 24 hours for that flooding to occur, whereas the photo on the right could have been 15 minutes. So we don't know. So intensity is controlled by infiltration. So how hard that water comes down and hits the surface, and how fast it can drain through the openings in the joints. And quantity is detention, or sometimes called volume control. What's the total capacity that a permeable system can contain that water in the base? So let's start by talking about rainfall intensity. Now this chart comes from the Illinois State Water Survey Bulletin 70, and it's looking at duration of storms from 5 minutes to 6 hours with an intensity inches per hour from the 1 year to 100-year rainfall events. Now if we look at the highlighted areas there for the 2, 10, and 100-year events, we're talking about a 5-minute intensity. So that's going to be the heaviest the water is going to come down for 5 minutes, and it's showing that inches per hour be 4.32 is the rate, inches per hour. Now that doesn't mean for that 5 minutes you're going to get 4.32 inches. You got to divide that number by 12, which would equal 0.36 inches of water, or about a third of an inch of water. If you drop down to the 1 hour, you're looking at 1.43 inches per hour. So over that 1 hour period, you would get a quantity of 1.43 inches of water. And likewise, if you drop down to the 6 hour, where it's showing 0.38 intensity, that's the rate, you have to multiply that number by 6, and that will give you 2.28 inches of total quantity. So that's the difference between intensity, or the rate at which the rain comes down, versus quantity. So this is actually inverse for the quantity when you think about it. I use the 2, 10, and 100 year because when you talk about quantity, those are usually what storms you design to, the 2, 10, and 100 year events. But the most important thing to realize when it comes to intensity is that the infiltration rate of the permeable surface must exceed that intensity. Otherwise, water will start to drain off the surface into other areas. So that's an important thing to understand. Now the way that we measure that, we use ASTM C1781, the standard test method for surface infiltration rate of permeable unit pavement systems. And what this does is it gives you a test that you need to administer using a single ring and some water, and you pour on the surface and you time that and you measure it. So in these photos, what we've done is we've taken a 5-gallon bucket and we've cut the top off to create this ring. We know the diameter of the ring, and we'll put some plumber's putty in there to clog it up so the water won't bleed out underneath this ring. We'll pre-wet this area, and then we'll take another 5-gallon bucket and we'll put 40 pounds of water in it, and we'll pour that into that ring and we'll time it, and that will give us a duration for how fast that water drains through there. And so we can calculate that, and that's what this test method explains. So we've tested all our permeable pavers, and so we've put them in this chart to make it easy to read here. And so we have the paver. In the first column, we have the joint material, which is kind of the common joint material we see used in real-world situations. Then we have the joint width, showing the different, in millimeters. And then we have the void space ratio. And when we talk about void space ratio, we're looking at the footprint of the paver, not the surface, because some of the spacer lugs will stick out and kind of cause that water to bottleneck as it flows through there. So we've installed all these different paver options at our test facility, and we've actually measured these infiltration rates. So you can see the column there. For our pavers, they range from 327 inches per hour for the 𝐸 at 10 by 10, all the way up to over 1,000 inches per hour with the Ecolok paver. And so it makes it nice to be able to compare these different products right here in this chart. Now what you see on the right in the green columns is the minimum infiltration rate for rainfall intensities. So if you look at the 4.5, 6.5, and 11 inch per hour rainfalls, those are really the 2, 10, and 100-year rainfall events I just talked about in Bulletin 70. So the way that we calculate these quantities here, these amounts, is by taking the void space ratio of 5.8 and dividing it into the inches per hour. So basically 4.58 inches per hour divided by 0.58 or 5.8% will give you 77.586 inches. So we round up to 78 inches per hour. And that's how we calculate that. Now the reason it goes up in numbers for these other storms is because you have more rainfall for that event. So all the water has to drain off the surface of the paver through those joints. So you need to be able to get that water off there faster. So that 78 inches represents about 13.8% of the maximum infiltration capacity. So of that 560 initial, it's dropped down to 78. That's 13.8% of the initial 560. Now, if the infiltration rate would drop down to 50 inches per hour and you had a 2-year event of 4.5 inches per hour intensity, you're actually going to start to generate some runoff because the water cannot flow through those openings in the joint fast enough. So keep that in mind. So another way to look at that is that 78 inches per hour represents that the joints are 86.2% clogged. And we'll talk more about that relationship here in another second when we get to maintenance. But just to point out how that works and how we calculate these numbers. So it's a very important thing to realize because you do have a lot of bounce there from 560 down to what a 2-year storm would be at 78 inches per hour. Now I want to talk about quantity and capacity. So before I do that, I just want to mention that I do use a lot of projects from Chicago here. Again, I just want to point out that regardless of where you're at, you're going to have very similar conditions for most of the Midwest and Northeast where the Unilock locations are at. Unless you're in like Florida or the Gulf area in Texas where you have hurricane type rainfall events or along the East Coast, you're not going to see too much difference from these numbers. So if we look at the high in New York at 3.85 average inches per month, and now that's quantity again, to the low in Detroit at 2.58 inches per month average, that's kind of the range. Chicago's right in between there, about halfway at 3.25 average inches per month. So it makes a good case study for these examples here. So when we go back to the Illinois State Water Survey Bulletin 70, now we're going to look at rainfall quantities. And for stormwater calculations, they always look at the 24-hour amounts for the 2, 10, and 100 year. So those are the most common that you see used. For a 2-year rainfall for 24 hours, the quantity would be 3.04 inches. For the 10, 4.5, and for the 100, about 7.5 inches of rainfall. So just keep that in mind when you're looking at comparing to your community what those rainfall events are. Now, one often misinterpretation of these different events is that it only happens once every 2 years or more commonly once every 100 years. And you'll see people on TV all the time say, oh, I've lived here my whole life and we've had 2 100-year rainfall events in the last 2 years, and you're only supposed to have one every 100 years. Well, that's not correct. It just means that there's a 1 in 100 chance that you're going to have that size of rain hit your area. To put these numbers in perspective, Hurricane Harvey, when it came through Houston in 2017, dropped over 50 inches of rainfall in 24 hours. That's an incredible amount of rain. In Illinois, a 24-hour 1,000-year event is only 10.5 inches of rain. So that 1,000-year event is a 0.1% chance of happening. So when you think about a 2-year storm, 50% rainfall. So if you're seeing a storm come through, on the radar coming towards your area, and they say it's going to be a 2-year event, that just means that it's a 50% chance you're going to get that amount of water, 3.04 inches in your area. So how can permeable pavement be effective with these different rainfall events? Well, we know from the USGS that 1 inch of rainfall over 1 acre is going to generate 27,000 gallons of water. Well, that's quite a bit of water. But we also know that a 1 inch rainfall over 1 acre, and if you use a permeable system with about 12 inches of base material with about a 40% void space, and those are pretty typical type numbers for void space, it's going to be able to contain 130,000 gallons of water. So it's only using about 20% of the capacity for that 1 inch rainfall. So I've highlighted down here the 5.11 inches rainfall. And if you remember back from the last slide, 4.5 inches is about a 10-year event. So this is just over a 10-year event. And we're looking at, again, 43,560, 1 acre with about 13 inches of base. So it's going to generate 138,000 gallons of water. The capacity for that 13 inches of base is about 141,000 gallons of water. So you're looking at 98.3% of capacity. So it's almost completely filled up. So that's quite a bit of water, and you're starting to reach capacity. If you drop down to the last example, F here, 7.4 inch rainfall, which is almost a 100-year rainfall event, we're showing an 18-inch base in this case, and so it's getting up to 102.8%. So it's maxed out the base depth of water, and now it's starting to generate a little bit of water off the surface. So that's a good way to look at it. That 5.83 inches of storm is about 3.8 gallons per square foot per hour. It's quite a bit of water. So I've already mentioned the average rainfall event in Chicago is about 3 inches, or about 35 annually. So that April 19th, 2009 stormfall was a pretty good amount, 5.11 10-year event. Now, volume control, every jurisdiction is going to be different, so you really need to look specifically at your area. But let me give you an example here for the Metropolitan Water Reclamation District in suburban Cook County, Illinois. So from their technical guidance manual, they have the same rainfall events, the 2, 10, and 100 year from the Bulletin 70. And again, if we look at a 24-hour period with a 14-inch base, we have those different percentages there for the 2, 10, and 100 year, 54, 80, and 135. For that 100 year with a 14-inch base, we're actually going to drain off about 2 inches of water off the surface onto another area because the base isn't deep enough. So if we'd upsize that granular base to 18 inches, you're going to catch a lot more water, and you're only going to have about a 1/4 inch of runoff on that surface. So if we go back to our chart and we put it back in this chart format, and this is something that we can send out to you, and you can have this spreadsheet, and you can plug in your own numbers and create your own percentages for this. So we're happy to do that. Again, this is showing the 2, 10, and 100 year events with a 14, 18, and 22-inch base, and just shows you the percentage of those areas. And then for the 10-year here, you can see some cells that are in red. That just means that it's maxed out that system. You're starting to see water run off the surface of those pavements. We've also put this in acre feet as well, so you can look at the acre feet, not just gallons, because a lot of times when you do your detention calculations, you're going to be using acre feet and not gallons. So that's something to mention. So when we look at historic rainfall data, you can see here the Center of Neighborhood Technology put together a year's worth of rainstorms, and they realized that 98% of the storms are 2 inches or less. So if you think back to those 2-year rainfall events, we're looking at 3 inches. So most of our rainfall events are not even a 2-year rainfall event, which is 3 inches. So 98% are 2 inches or less. 95 are 1 inch or less. And if you get down to less than an inch, you're looking at, the majority of the storms that come through our area are 1/4 inch, 1/2 inch, maybe 3/4 inch rainfall. Again, they're not generating a ton of rainfall amount. And so that's why permeable pavement, not only can it capture the water off the surface, but it can drain into the base and be stored in the base. So that's that relationship between surface infiltration and volume control and the quantity. Okay, so you're probably wondering, well, what's the benefit for using permeable pavement in regards to climate change? Well, if you look at this graphic here, what this is showing is that the heaviest 1% of the daily precipitation from 1958 to 2012 have increased across the U.S. So as low as 5% on the West Coast, as high as 71% up in the Northeast area. And so what we're talking about, that 1%, that 99 percentile, is those basically 2-inch storms, which in the Midwest is generally about 3 inches or so. So remember that last slide I was saying 98% of our rainfalls are 2 inches or less. We're really talking about these larger than 2-inch storms. So just in the Midwest alone, we've seen an increase of those by 37%. And so how is this happening? Well, when you burn fossil fuels for like natural gas and gasoline for automobiles, you release carbon monoxide into the air. So the air will expand, and when it expands, it's able to hold more moisture. So as that air is floating along and it hits a cold air mass, then it's going to drop that water, and you get those heavy, intense storms, you get those rain bombs. And when the water comes down super heavy, it's going to want to run off those impervious surfaces and create flooding issues. So by using permeable pavement, you can capture that water because it can run off the surface into those openings of the joint and back down to the base, and you can slow that water down to prevent that localized flooding. Otherwise, you're going to see more and more people on the news, and I'm sure you have already, where they come out and they say, oh, I've lived in this area my entire life and I've never seen flooding like this before. Well, that's because of these rain bombs and these larger storms. We're seeing more and more of them. They are increasing. So as you look further downstream at the next 20 years or so, we're going to see an increase of these extreme precipitation events, anywhere from like 8 to over 20%. And so if you don't have a stormwater ordinance that has green infrastructure in place for permeable pavement, green roofs, rain gardens, rain barrels, and things like that, you're going to see more of this flooding. So it's a good reason to try to talk to your municipalities or your jurisdictions about stormwater and get them to incorporate these things, because they can help. Because the existing stormwater ordinances just can't keep up with the amount of urbanization and these climate change issues. So it's a good thing, because permeable pavement can assist on preventing that localized flooding by incorporating them on each new development. So again, we want to balance that site. So let me show you an example here. So I'm going to look at 2 years for Cedar Rapids, Iowa, 2010 and 2009. Back in 2009, they had a really heavy precipitation from April through August, and in August they had a relatively large storm. For the month, they had a total rainfall of about 14.36 inches. And so if you think back to our averages in the Midwest here, right around 3 inches or so, that's a pretty big storm. Their typical monthly average from 1971 and 2000 is only about 2.78 inches. So again, they're in that same kind of range, that 3 to 3.5 inch rainfall for all like the Unilock locations I mentioned. So that is quite a bit difference for that 1 month they have 14-inch rainfall. So if you look at 2000 through 2020, that's increased even to 2.93. So they're slowly starting to see that number tick up as well. All right, let's drill down on that rainfall case study for Cedar Rapids, the month of August 2009. And let's assume that the soil conditions out there are very poor soils, ranging from 1/10 of an inch to 1/2 inch per hour of infiltration. And we break down that storm by day. We can start to look at the clusters of when those storms came through the area. And if we drop down to August 7th through the 10th, we see that they had 3.1 inches of rainfall for those 4 days. And we know that the time of concentration for clay, loam, silty clay, loam soils would be about 34 hours. So it's going to take that long for that 3.1 inches of rainfall to drain into those subgrade soils. Now, before the next major round of storms came, they had 120 hours. So there's plenty of time for that water to be absorbed into those subgrade soils. Then from August 16th through the 21st, they had those 6 days, 3.74 inches of rainfall. So the time of concentration for that water amount would be 41.5 hours. Now they had 72 hours before the next major round of storms came through. So again, plenty of time for that water to infiltrate into those subgrade soils. And then the last 3 days there, the 25th through the 27th, they had 7.15 inches. So almost half their monthly rainfall in these 3 days. So the time of concentration for those 7.15 inches would be about 80 hours. So they had 96 hours until the end of the month, until the next potential rainstorms would come in. So again, plenty of time for that to be absorbed into those subgrade soils. Now, this is a very simplistic way to look at it, but I think it illustrates the point that a lot of these rainfalls are going to be small enough that the subgrade soils can absorb that water before the next round of storms come through. If not, this water can drain off to other areas. Once the subgrade soils become saturated, though, it makes it harder for them to absorb any water. So think of it as a sponge. A dry sponge is going to absorb a lot of water initially, but once it's wet, it really can't absorb any more water. So you do have to have that water moving through the subgrade soils or off to another location through under drainage and things like that. So just some reminders here. If you're working in a municipality that has established stormwater ordinance with permeable interlocking concrete pavers or any kind of green infrastructure, it makes it a lot easier to meet their requirements when it's in the stormwater ordinance. So you can use those explicit requirements and allowances to design your system. Sometimes there'll be incentives for using green infrastructure like permeable pavement, rain barrels, rain gardens, green roofs, and things like that. Again, it makes it easier to design your project so you can get this permitted, and that's really the main thing. You need to get a permit for this stormwater. There are some potential cost savings for using stormwater BMPs like permeable pavement, and that's because you can reduce that volume control or minimize the infrastructure going into that for that stormwater detention. If you do not have any kind of ordinance with green infrastructure, traditional stormwater ordinance make it a little bit more difficult to get them to allow permeable pavement. And that's because there may be no credit given for stormwater detention. So they may still require you to have an underground storage tank or a surface detention. No incentives to use green infrastructure. When that's the case, it makes it harder to build that into your cost. It can make it difficult to actually design because it lacks guidelines and any kind of requirements for those systems. And then you can't calculate it if they don't have those requirements. So that's the biggest challenge. And then if you're going to have that traditional type system to use permeable pavement, it's going to add additional unnecessary project costs because you have redundancy there where you have both systems. And so that might shy developers away from using green infrastructure. Now keep in mind again, if it's in the stormwater ordinance, or they will allow you, if it's not in the stormwater ordinance, to use permeable pavement, it can be a cost-saving thing to use. All right, we'll switch gears back to a new benefit, and that's winter performance. So here we have a project called Maxwell Street Market, south side of Chicago, where the Illinois EPA put probes in the soil to measure the temperature during the winter time and also look at rainfall quantities and things like that. So back in January 16th of 2009, the air temperature was -7 degrees Fahrenheit, but all the probes that were in the soil were still above freezing. So they ranged from 33 degrees to 38 degrees Fahrenheit, meaning that if on this day, if it snowed, 3 or 4 inches of snow, and the next day it got up above freezing and it melted all that snow and it drained into the base and into the subgrade soils, they would still be able to absorb that moisture, that water, into the subgrade soils. Even when the ground is frozen, it could drain in there. In this case, it still wasn't frozen, so it wouldn't be as much of an issue. What we've seen in other case studies similar to this is it takes longer for that subgrade soils to freeze once the air temperature drops below freezing, and they warm up quicker, and that's because it's insulated and there's some breathing action from the air flowing through there. So that base temperature is going to remain above freezing much longer. Now another benefit is you can still snowplow permeable pavers just like you would non-permeable pavers or other impervious surfaces like asphalt and concrete. We suggest that you do use a rubber tip on the plow to prevent any kind of scraping or rust marks, and I'll show you an example of that here. Here's a permeable paver system that was installed, and you can see where they pushed the snow from the right side over to the left side and packed it up against that parking island, and you can see the curl of the snow plow. But essentially, it got up most of the snow off that surface. Now, if they go out there and put down some de-icing chemicals, it's going to melt off and drain through those openings in the pavement. Now keep in mind, if you do use a steel tip on the plow, it's going to scrape off some of the steel onto the pavers, and it's going to leave rust marks. It's going to oxidize and leave rust marks. That's not damage to the paver itself, it's the rust that's left behind from the steel on the plow. Now you can see, if you look towards the center of the screen there, where there's an area that's kind of a triangle area, that's paver was tipped up just a little bit and the snow plow was grinding that surface off, but it didn't split it. It didn't rip out the paver. It still stayed in place and intact, but you do see some grinding action. So that's one of the reasons we suggest using a rubber tip plow. Now I want to talk about preventative maintenance and restorative maintenance and what equipment is used for these type of applications. Keep in mind that you don't have to have high-tech equipment to maintain your system. So the first one here, you could just use a broom. So if someone spills mulch on the surface or grass clippings, you can go out there and brush those off fairly easy. Get them out of the joint so they don't get packed down in there. Shop vacs also work. Again, if someone drops potting soil into those joints, go out there and vacuum it up before, again, it packs in there and dries and prevents fast infiltration. You can also use backpack leaf blowers. A lot of landscape companies that go out and do maintenance, they have these already, so they should always be blowing off the surface of the permeable pavement. They could do large, plaza areas or sidewalks very easily with this to get any kind of grass clippings or pruning from shrubs and things like that off the surface of the pavement. Rotary brush sweepers work great. Not only do they work great of getting debris out of the joints, but they also work very well in the winter time. So if you have, for example, a college campus that needs to maintain sidewalks for safety, which obviously they do, these work well because when you get less than an inch of snowfall, a lot of times it gets packed down from foot traffic. The rotary brush will help break up that snow that's packed down and get it off the surface. So these can not only clean the joints but also be good for snow maintenance in the wintertime. Just make sure that you use a poly brush and not a steel brush on those rotating bristles. There are some industrial street vacuums or sweeper vacuums that are out there that will help suck up any kind of debris on the surface. Those work well to get off loose type material, and they should be used on a regular basis, a couple times a year at least, to clean the surface. You can power wash and blow out the joints with the pressure washing. That does help clean it very quickly. And then the worst case scenario is you can remove and reinstate the pavement. So in other words, if you had, let's say, a development site going on and the truck traffic going in and out with supplies packed in dirt, you can always pull that area up, clean the stone setting bed, and then replace it and zip it back up, and no one would ever know that you had the pavers removed. So that's another great example. Now I consider most of that equipment more in the preventative category. Let's talk a little bit about the restorative side. Now this is a street vacuum that has a rotary brush that spins around and flips any kind of loose debris out in front of the vacuum plate, and that vacuum plate is going to suck up all that loose material. Generally it's going to pull out between 1 inch and 3 inches of material depending on the amount of suction and how much clogging is occurring, but it should restore the infiltration rate back significantly higher than what it was prior to this vacuuming. Now this I would only do maybe once every 10 years as long as you're doing the preventative beforehand. This is really kind of a worst case scenario to come out here and do the restorative. You want to avoid having to do restorative maintenance. Now, here's a new piece of equipment. This is a vortex cyclone machine, and it kind of has a deck similar to a lawnmower, except the blades are vertical, and these rotate around very high speed along with a power washing device underneath there. So it will spray the surface and then vacuum it up at the same time. So very effective in cleaning the surface. As a matter of fact, the Interlocking Concrete Pavement Institute did a little test, and they used the same infiltration test that we do, the 𝐸𝐸-𝐶1781, to check the infiltration rates prior to using this piece of equipment. They found that the porous concrete and the porous asphalt and the permeable interlocking concrete pavers all had very low infiltration rates. 20 inches or less for the concrete and pavers, and 42 inches for the porous asphalt. But after they took the cyclone machine and went across with one pass on the permeable pavers, they restored the infiltration rate from less than 20 inches per hour up to over 327 inches per hour after one pass. They actually did not need to go back and do a second pass. Whereas the porous concrete went from less than 20 inches to, after two passes, 80 inches per hour. So yeah, they had a significant increase in their own infiltration, but the permeable pavers are still 4 times more infiltration per hour than the porous asphalt and the porous concrete. So a dramatic difference in terms of the performance of those different systems. PaveTech has come out with their own as well. These are walk-behind devices, one that power washes and one that does the suction device. So these are hooked up to a truck that has the equipment, and you just walk behind. So it's going to take a little bit longer to do large areas with this, but great for plazas and sidewalks. Back the surface infiltration rate with maintenance, we've created this little chart here that kind of explains that relationship. So if you look at the left side here, it shows you inches per hour from 0 to 700, and then across the bottom is years. So we go from 0 to basically 30 years. And in this theoretical example, the blue dotted line that goes from 700 down to 15 years would be if you did basically no maintenance. And so we're assuming that there's going to be a drop in performance of that surface infiltration rate. And so we're just using this as an example. Now, what else is going on here is if you do your minimal preventative maintenance, where you go out there and you sweep a couple times a year and pick up any loose debris, you might extend that out a few years. So the dash dot dash line that's in the purple goes down, and it goes out to about 20 years or so. And you can see here across the bottom we have the 2, 10, and 100-year infiltration rate. So if you think back to where that intensity that I was talking about, the 4.5, the 6.5, and the 11 inches per hour intensity, those are kind of like your lines of factors of safety, you know, to think about when you need to do your maintenance. And so if you go out to about 15 years there with the purple line, you can see where we're doing some restorative maintenance, and it jumps back up to above, you know, right around 180 inches per hour. And again, you're extending that line out by doing your preventative maintenance over time. So it's just a good way to think about when you need to do your maintenance and how often. So the more preventative maintenance you can do, the longer you're going to be able to go before you actually need to do the restorative maintenance. Again, if you have any questions about this, feel free to reach out to me at brad.swanson@unilock.com. So here's one of the challenges with porous concrete. The durability is not near what it needs to be for commercial applications in drive areas. So in this example, they put in this porous concrete in a downtown diagonal parking, and after one winter they started seeing failing. And you can see in this photo here where they snow plowed down the parking area, and they piled the snow up at the end here, and when the snow melted, it left behind any loose concrete that had ripped off the surface. And you can actually see where they went through here with a vacuum and or a sweeper, and they can see the lines where that sweeper went through there and tried to clean it up, and did not work. And so they did not get very good infiltration rate even after that first year, because the surface was completely deteriorating and falling apart. So they had to replace it. I think after about 3 years, they put in Unilock permeable pavers. Part 4, design considerations. This is where we're going to talk about the solutions, options, and components of the permeable system. In this photo here, this is a school play lot where they have this different arrangement of lane patterns here in a grid format, and this is so students can go out there and kind of line up and create their own games using the pattern on the surface here. This is Eco Priora with a exposed granite and brush finish. So like any project, design planning is critical to the path towards success. And in this case with permeable pavement, we always want to look at the goals of the project. Are we trying to improve surface infiltration? Is this detention pond size? Are we using the water for something else? So we need to know what the site soils are. So when you get your geotech report, you should find out what the porosity of that soil is and what type of soil. There can be some cost expectations, so know going into this that having a redundant system is going to add cost, and so look for ways to be efficient with your design. There could be some environmental impacts. Now it's recommended that you stay at least 2 feet above the seasonal high groundwater. Keep that in mind. And you don't want to use this on hot spots like, let's say, for junkyards and things like that, where you might have chemicals going back into the ground. And then each jurisdiction or your local regulatory requirements are going to be different for your area. So you always got to look at the municipal stormwater ordinance to see what they're going to allow and not allow. Now conceptually, there's 3 ways to design the system. The first way would be if you have kind of very poor soil, so like that heavy clay soil where you get like 1/10 of an hour of infiltration or less. You're going to want to have some sort of under drain pipe in there, a perforated pipe, to capture that water and drain it out of the base. So this could go to a storm catch basin or through a manhole, and that's going to connect to your municipal system. But essentially you want to have this be able to drain, because most of it's going to not be able to do that in those poor soils. The second way would be if you have fairly good soils, you're up around 1/2 inch an hour or more. That's kind of our rule of thumb, 1/2 inch an hour. You can raise that under drain pipe up so you can capture that first 1/2 inch of rainfall, let that allow infiltration back in the subgrade soils. And then if you get the really big storms, again, this could outlet to some sort of municipal system through a manhole, and that manhole might have a restrictor plate in it to slow that water down and back it up into this stormwater base and use that as your detention. And then the third way is like a couple of the case studies I mentioned earlier where they have high infiltration rates into a sandy soil. You potentially could eliminate all the underground infrastructure and let all the water just drain naturally back into the subgrade soils. Now besides the infiltration rate, you got to look at the structural capacity of your system. And when you start to drive on these things and with wet saturated soils, you can't have deflection at the surface. So the thicker that you're going to make that base, the more it's going to spread out in that cone-shaped fashion. And think of that as kind of like a snowshoe on top of snow. It creates a stable base for those pavers the further depth you have. And here's another example of a heavy-duty parking lot with bus traffic out at the Morton Arboretum in Lisle, Illinois. And what I like about this project, it was installed in 2004, so we've seen 16 years worth of use out of it, and it's held up incredibly well. There's no surface deflection or rutting anywhere. They've done very little maintenance in terms of preventative maintenance of the joint opening. So we did notice when we measured the infiltration right here a few years ago, it had dropped down to about 45 inches per hour, down from the initial 1,000. So it's definitely a candidate that needs some restorative maintenance. Now in terms of the granular base and sub-base, all the material is crushed angular stone. You want these to lock together. There's no fines in the base or sub-base. Typically they're going to have about a 40% porosity or void space in those stones. And again, you're going to see infiltration rates 500 inches per hour or more. And generally these are pretty single size in their stone size. Now our rule of thumb is that about 3 inches of base will store about 1 inch of water, and we say 24 hours. You really want that to drain out, but with the California bearing ratio you have up to about 72 hours before your soils are going to start to become compromised. But I would try to limit that to 24 to 48 hours. You really want it to drain. Now For the base reservoir area, you're looking at ASTM number 57, which is a about 3/4 to 1 inch size stone. Again, crushed angular, and it's going to have that 500 plus inch per hour infiltration rate. And then the sub base, you may or may not need. It just depends on the soil type. That's going to be ASTM number 2, so it's a larger 3-inch stone. And now the 57 will actually choke out into the number 2 stone, so you do not need any geotextile between these layers. And then the number 2 will actually add some structural thickness over the subgrade, so you may or may not need a geotextile under that between the subgrade and the subbase. It just depends on what type of soil it is. Typically, if you have a sandy soil, you're going to want some sort of geotextile underneath there. But these stones will allow for very rapid infiltration through the system and also good detention. Now, the setting bed and joint material may or may not be the same material, but typically the setting bed is an ASTM number 8, so it's a 1/4 to 3/8 inch chip. Again, high infiltration rate, 1,000 inches per hour. What makes this nice, it's small enough that you can screed it like you would a sand material and then get a nice level setting bed for those pavers to set on. So this here photo, you can see the number 57 in the foreground and then the number 8 smaller stones setting on top of that. Again, there's no geotextile between these layers. They're going to separate when you spread these out, and so that works very well. So when you kind of look at these stacked up here, you can see the different stone sizes compared to the pavers here. So the number 8 stone here in the first photo on the left is only about 1.5 inches thick, and the pavers will sit directly on top of that. And then on the far right photo here, you can see the combination of the number 57 stone and the number 2 stone. And one of the things that I'll mention here in a second is the containment curb. You're always going to need some sort of edge restraint with the permeable pavers. Now, regardless of whether you use porous concrete or porous asphalt or permeable pavers, they use the same base and sub-base materials. The pavers are going to use that ASTM number 8 setting bed though. Now, when we talk about the joint material, depending on the joint size, you may or may not be able to use that ASTM number 8. In Illinois, we use the 𝐸-CA16, but generally speaking, the ASTM is a number 9 stone for anything 1/4 inch in size. Once you get up to around 1/2 inch, then you can start using the ASTM number 8 size stone, which is a little bit larger. So the number 9 stone is a little bit smaller. It sweeps in easier to the joints for equal priora and still allows for good rapid infiltration. But we have looked at many different types of joint material, and we created this chart to kind of compare the different materials because we have a preference in how fast the water gets off the surface, but we also want to have good lockup. So there's a relationship there where you can have better lockup by using a smaller material, but then you get a slower infiltration rate. So you really want to use the biggest aggregate size that you can to fit in those joints. So we've created this chart to help make that a little bit easier. The red dashed line is for the number 16 stone, and you really kind of want to be above that. Anything smaller starts to slow down that infiltration rate. And then across the bottom we have 2 examples just showing the difference between how much material is smaller than the number 4 stone, and for this fine Vulcan material, you're looking at 93% being smaller than the number 4, whereas the ASTM number 8 on the right there, only 20% is smaller than the number 4 size. So you're going to get really good lockup with the Vulcan fine joint material, but you're going to get much better infiltration rate with the ASTM number 8, and you're going to get more longevity out of the infiltration rate off the surface. Now, some products don't use a joint material, which we think is incorrect because the joint material has a purpose. Not only is it going to filter and keep the debris at the surface there so you can easily sweep it off, but it also locks up the pavers and prevents them from moving around. So if you remove that joint material, you're going to start to see things shift and move out of place. So it's not ideal to remove that. In this case, you can see this paver here is widened out more than a half inch, which we would consider not accessible. It also could capture a bike tire if you're not careful, or a roller blade, so it's something to be concerned about. And you notice in this photo, it's just capturing a lot more debris. And once that gets down in there, it's going to be much harder to get out of those joints. So that's a critical thing to consider, using a paver that can take and accept joint material to give lockup and also help out with keeping contaminants from getting into that base material. Okay, I've saved the best design consideration for last, and that's the permeable pavers themselves. So if you're looking for spec sections, master format would be in Division 32, Section 1413 for the non-permeable interlocking concrete pavers, and the .19 would be for the permeable interlocking concrete pavers. Now the only difference between these sections is the materials that go in it, the base material, subbase, and setting bed. With the permeable, as I just have gone over, it's all open graded material, whereas the non-permeable pavers might have a dense graded base and a sand setting bed depending on your project. But there's lots of different spec section out there, so make sure you're using the 32, 14, 13 for concrete pavers. Some of the other products out there use different sections and they could be confused. It's better to have different sections for these different paver systems because there might be some subtle differences in how they're installed. But within the concrete pavers section, we manufacture all these pavers to ASTM C936 standard specification for solid concrete interlocking paving units. And what that looks at is any paving unit smaller than 101 square inches is going to follow this section. Anything larger than 101 square inches will use a different manufacturing ASTM standard. But for this, we're going to look at three things here, three additional tests: ASTM C140, ASTM C1645, and ASTM C418 for abrasion durability. Now the C140, the absorption and compressive strength, is really kind of the nuts and bolts that you can compare to other products. The freeze thaw durability is really specific for concrete pavers and measuring how well they hold up to freeze thaw. And so they'll put the paver in a tank of 3% saline solution and they'll freeze it for 50 cycles, and it can't have a certain amount of deterioration or breakage off that product, so it's limited to that amount of material. But let's look at the C140 specifically. And the quality control for C140, the minimum PSI is 7,200 per unit with a maximum absorption of 7%, and you need to have an average of about 5% absorption. We actually have a higher internal standard at Unilock. Our minimum PSI is 8,500 with about a 4% average absorption and a 5% max. And we also have really good dimensional accuracy, plus or minus 3/64 of an inch. So very, very dimensional tolerance for the length and width on the pavers. Now the average poured in place concrete might have a PSI after your 28-day breaks of anywhere from 2,700 to 5,500 PSI. Porous concrete is going to be even less than that. So you're leaning in the mix out, less concrete, less aggregate. It could be as low as 2,700 to 3,300 PSI on your averages. So it just depends on how that's made and what it's for. We send everything out for third-party independent test results, and this is an example here showing you for the 𝐸-OptiLock material manufactured in 2018 that the compressive strength was an average of 11,000, which is a really good number compared to our minimum of 8,500, with an average absorption of about 4.5%. Now I see a lot of our test results will be closer to 12, 13,000 in some cases. I've seen them high as 18,000 for some of our wet cast material, and absorption I've seen down in the high 2% range, 2.9, 3% for some of the low end. So that's important because the less absorption you have, the less expansion and contraction you're going to have with that product, and it's going to be much more durable. All right, let's take a look at the aesthetics of these pavers now. This is the best part here. So as you noticed before in the chart back when we were talking about the infiltration rate, we had a whole list there. Let's look at the visual of these now and show you the differences between them. The first one here we're going to talk about is 𝐸-OptiLock, and we're showing this configuration the way that it would be mechanically installed. This is what we call an L-shaped paver. and this is made to really resist the forces of cars turning and braking. So it's ideal for large parking lots. The void space is about 7.3%, and the joint width is right around 12 millimeters, or just under a ½ inch. And so when you see it laid out in a parking lot area here, it looks very much like a cobble surface, but when you get up close, you can see that there's actually joint material in there and the L shape of the paver. As I mentioned just a second ago, this is an L shape, and this illustration really shows it well, how it resists that turning and twisting motion based on that L shape paver. It was used out at the Museum of Science and Industry that I talked about earlier in my case studies. It's been used at several college campuses for large parking lot areas, and really is a great paver for mechanical installation. The second one here is 𝐸𝐸, and this one is also able to be mechanically installed in this configuration here. This has about a 7% void space. Now this joint width is only about 7 millimeters, or a ¼ inch, and the photo on the right here shows where it's actually picked up mechanically installed. Now this is if you don't take out the 5x5, the half stone pavers there. You can stitch this together mechanically so that it doesn't have any of the 5x5s, but then you're scrapping that material and throwing it out, so it would add a little bit of cost to do that. So most owners elect to keep those in and just do the similar representation of the herringbone. Now this is if you'd install it by hand. You can see here this is a project where they used a brush finish on the surface. The light really reflects off that, pretty cool. You can see that grain in the paver surface, and then they painted on some parking stall stripes here for this. It's been also used in a lot of parks and a lot of college campuses as well. So this is a park here in Chicago called Mary Bartlemy. You may have seen this in some of our ads that are in Landscape Architecture magazine. But this has, again, a brush finish and then a smooth Premier finish on the surface. Here's another example of a brush finish surface at another a park area. And then it's been used in large parking lots. In this case, they had a Premier finish in a color called Autumn Red, which is a blended color. But you can see they elected to hand install this area and create a true herringbone pattern, but you can see that difference in color. Now this is a fairly new product. Now what makes this unique is that it's a 4-inch thick plank paver, so it kind of has a continuing running bond type pattern. This will come in a true rectangle, and then you have to offset mechanically to get that 3.5 or 3 3/4 inch offset with the machine, and that creates the bond lines from being completely straight. Again, it's been used in plaza areas, but it's also been used in large parking lots as well. A new paver that we came out with back in 2014 was this Eco Promenade. It's a 3x12 permeable shape, and it was designed for the Navy Pier project, which if you go on our website, you can find video, and we have a description of this project as well. And this has been used on the pier area in the park, as well as many other projects around Chicagoland and out on the East Coast. It's performed very well. It has a very high void space ratio, over 10%, so you get really good infiltration off the surface. And because it's 4-inch, you can actually drive semis across this space. Here's a project where they have it in a turnaround drop-off area. This is in a color called Steel Gray, which is a Premier finish. And then also in, again, pocket parks, this is a couple different colors here to create some visual interest. And once again, you can see the Sears Tower back there, Willis Tower photobombing my pictures. Now this is a truly unique product out there called Town Hall. This is a wet cast material, so it's made a little bit different, but you're not compromising on your structural integrity of the product because it still has very high PSI and very low absorption rates. Now if you use this in a running bond or a herringbone pattern, it has about a 6.5% void space ratio, and it has a little bit wider footprint on there, so you can see kind of the void spaces in that lane pattern. But a great product. This is a project where they use it for a college, on a college campus, as a north-south spine through their campus. Here's a product called City Park Eco, and it's a hexagon shape, 6-sided shape, with about a 1 centimeter joint 10 millimeters, and it has a low void space ratio of 4.2%, but it still has a very high infiltration rate because of the wider joint size, so you get good water flow through there. And this product is actually really good for drive areas because it does lock up. It makes it kind of unique because it can lay in 6 different directions, so you can create patterns going different directions very easily with this product. Now here is a permeable paver that's an ashlar type pattern where there's actually 3 stone sizes in one configuration. It has about a 4.4% void space ratio, but again it has a different look to it because of the cleft in the surface, and this actually has a premier finish, and the color shown here is a Bavarian finish of the paver color, but really makes a nice plaza paver. You could still drive light duty vehicles across this. It's only 7 centimeters thick, about 2 3/4 inches, but certainly a nice product for plaza areas. The reddish brown paver in the center there, that is the Eco Priora as well. Here's another great paver that can be used in drive areas called 𝐦𝐵𝐞 with a 5.6% void space ratio. It gives you a really authentic look to a granite cobble, and this has a wash surface with granite, so it's like it is our series finish, the exposed granite material. It makes a really nice durable pavement surface that's not going to weather or fade over time. Which kind of leads me into my next area of design considerations, and that is that surface material. Not all permeable pavers are apples to apples in terms of their aesthetics. So there's different finish options that we have available for most of our pavers, whether it's modeled, exposed granite, smooth, brushed, or textured. They're all available to you on most of our products for your permeable pavers, and we actually have some products that we can do factory coatings on there to make them stain resistant, so keep that in mind as well. We can talk about that when you have a project where you want to use something like that. Now, with a lot of those different finish options, we make what we call a face mix paver. Our brand is Enduracolor, and what this is, it's a 2-step process that has a larger aggregate size in the base and then much finer material on the surface. So it's all done on the wet side and compacted so that it never delaminates or pops off. It's going to cure together and be a very, very strong product. But by having the face mix, you have a much better wearing course on the surface, so it's not going to fade over time, and then you get the benefits of the larger stone on the base for the strength. So in this case we have a brush finish, and that's a good example to kind of show you visually what it looks like and see the way the sunlight really helps pop out those brush marks. But there's several different options out there. So we have Umbriano, which is like kind of a model finish. The 𝐠𝐫𝐞 is a matte finish with a coated surface, so it's going to be very stain resistant. The series is our exposed granite material. 𝐸-𝐵𝐞 is our brushed surface finish. And then we have a couple different premier options, one smooth and one with a flagstone. Now the only flagstone we have currently is the Thornberry, which I just mentioned. And then we have a couple new ones out there that we haven't really done in permeable pavers yet, and that's Granito and Revila, which is a shot blasted finish. And then you also have the option for your classic through mix finish. We do make that, and we use a lot of that for the permeable parking lots that are larger in size to cut down on cost. But you can see in even that photo there's a little bit of the aggregate showing up at the surface, and so when those weather, you start to see the color wear off those aggregates, and you'll expose those aggregates underneath that surface, and that gives the appearance of fading. So when you use your darker colors like charcoals and reds, you tend to see that aggregate show up more than you do if you use lighter colors like buffs and grays and things like that. So those are all the design considerations in a successful permeable system. You do have the pavers on top, your granular base materials. You may or may not need your underdrain and geotextile, and then you always need to have some sort of edge restraint with a permeable pavement system, or even non-permeable pavement systems. You always need to contain those pavers. If you're looking for a typical cross section, you might see this being a very typical type section. You'll have your different stone materials layered up. You do not need the geotextile between those stone layers, only between the subgrade soils If they're sandy, if they're clay soils, you may not need that geotextile. Work with your engineer on that as well. And then the thickness will vary based on your project. Again, you may not need that sub-base material. You can use all the base material, the ASTM number 57 for your permeable system. And this would be a kind of a heavy duty system, and here we're showing the Unilock drive grid, geogrid material in between the layers, and that's for strength, not for separation, but really to keep that movement to a minimal so you don't have any reflective rutting on the surface. And then you also have your contrast to your non-permeable system. So this will have a sand setting bed and a dense graded base material. Now all these details can be found on our website at unilock.com. If you have any specific needs or requests, reach out to us and we're happy to help you find the right detail for your project. So I want to switch gears here and talk about the installation equipment. There is some specialized equipment to help speed up these larger projects. Now if you're doing something smaller than, let's say, 5,000 square feet, sometimes it can be faster and less expensive doing it by hand. But once you get up over 5,000 square feet, you can start to see some real savings, maybe as high as $1.50 a square foot versus manual labor of putting in these pavers. So these different machines will help speed up that, screening of the setting bed material, the installation, and also the sweeping of the joint material. All right, let's take a look at this mechanical installation device. Now this is when they were installing Morton Arboretum in 2004, and this picks up one layer off the bundle, which is about 11 square feet of the Ecoline product, and you can see you're going to set this down right next to the adjacent material. And with this machine, these are all loose pavers. They're not locked together, so you can see that one flip up on the corner. Then you're going to have someone come over and just kind of snug these up and tap them into place, and he's ready for the next layer. So in this little short clip, if you do the math on that, it works out to about 8,000 square feet per day based on how fast they can lay these. So it's all coordination. They could get up to 10,000 square feet per day per machine, and they can drive on this right away. So he's got the machine going across there. They just need to come back and sweep in the joint material, but essentially now they could phase in their parking and use this immediately the next day, which is another advantage to using permeable pavement versus other systems. Now again, I've worked on a lot of projects around Chicagoland. These are just some of the projects that I've worked on and how much pavers we have in the area, but you can talk to any of the Unilock reps in your area and I'm sure they can give you a really good list similar to this. So please reach out to them and ask them to assist you on any of your project needs. All right, part 5, lead information. Let's talk a little bit about where concrete pavers can help out in your lead projects. For version 4.1, there's really 4 categories for that. For the building product disclosure and optimization, you really have 2 areas: responsible sourcing raw materials and material ingredient reporting. So what that looking at is where the product's made in relation to all the raw materials and where it's going. So you need to be within 100 miles of your project. For material ingredient reporting, we actually have health product declarations for all our products, HPDs. So make sure you reach out to us on that. For using sustainable sites, rainwater management, the permeable pavement fits into that category perfectly because you can get credit for using permeable pavers on site. And then also for your heat island reduction, for non-roof and roof pavers. So for your parking lot areas, having a lighter material with a higher reflectivity is very important. So if we drill down on those, like I said, you can find your material ingredient reporting for the product disclosure and optimization. We have all those HPDs listed on our website as well as on Sustainable Minds. So make sure you reach out and grab those when you're working on your projects. And then for the reflectivity, I do like to mention that we've tested over 60 colors. We have 29 that achieve a SR solar reflectance of 0.33 or greater. And so the 0.33 is the initial requirement. Now after 3 years that drops down to 0.28. It's much harder for us to measure after 3 years, to coordinate all that with 60 materials. So it's just easier to go for the 0.33 or greater. I mentioned this new color here, canvas, because it has a solar reflectance of 0.33 with a very high recycle percentage of 15.4, and there's no added increased cost. Now this is a standard finish. You can see there in the 𝐸𝐸 in the photo here, but again, initially meets that, and it doesn't add any cost to your project to do that versus other colors. All right, well that's the presentation. I do have a quick commercial here for part 6 on Unilock and some of the resources. As you can see there, those are some of the locations for our different facilities. Now, I want to mention that we do have a full permeable paver detail sheet, and this gives you some typical type details for using permeable pavers, and just kind of a very generic starting point for your projects. We do have all kinds of catalogs, brochures. There's additional cross sections and details. We do have all our hatch patterns. Don't underestimate the use of our hatch patterns. Those are accurate, very 100% accurate in terms of laying out things, so it can be very helpful. But we also have CAD shapes of all our products. So if you need to zoom in and do a more detailed drawing, we can help you with that as well. We do have 3D SketchUp swatches as well on our website. So if you need to do some early concept designs and want to include that, we do have those available. So if you go to our architectural site on our website and go to resources, you can find that. We also have a bunch of project profiles that can help you kind of see similar type projects. Well, thank you for listening to this presentation. I really appreciate you taking the time. If you have any questions, please feel free to reach out to me at brad.swanson@unilock.com, or you can call me directly on my cell phone at 630-742-4168, and be sure to follow me on Instagram and LinkedIn. Again, thank you very much and have a great day.